Hey everybody, Cody from Alien Concepts here, in comfy clothes just to make a quick video. Seth and I are working on a longer one, but I wanted to just throw out some ideas and look at some articles of things that have popped up in the last few weeks. So, there's been a discovery of phosphine gas being released in the upper atmosphere of Venus, and this has the potential to be a biosignature of life. So, I'm going to start here on an article from The Atlantic, and this is titled "Something Weird is Happening on Venus," and it is written by Marina Corin. So I'm just going to come down here, and I'm going to go ahead and read directly from the article. And it says, scientists revealed today that they have detected traces of a gas in the Venusian atmosphere that, according to everything they understand about Venus, shouldn't be there. They considered many explanations for what could be producing the gas, known as phosphine, and settled on an explanation guided by what they know about our own planet. On Earth, phosphine, a toxic gas, is produced by microorganisms. I'm going to keep reading here and just get through these two other paragraphs. Quote, as crazy as it might sound, our most plausible explanation is life. Clara Sosa Silva, a molecular astrophysicist at MIT and one of the authors of the new study, has told to the author of this, Marina Corin. Before everybody starts screaming, she says, I need to emphasize that the discovery of phosphine molecules in Venus's atmosphere does not mean that scientists have found proof of alien life. The detection is simply evidence of a phenomenon scientists can't yet explain. The phosphine could be created by some form of life, or it could be forged by a chemical process that scientists just haven't seen before. Also, I realize I do not have an ad blocker because I'm a pleb. So, what we're seeing is there is the potential biosignature of life in the upper atmosphere of Venus. Now, we all know that Venus is a really inhospitable planet. We've sent rovers there that have melted before. The surface temperature is up to 900 degrees Fahrenheit, or something like 400 degrees Celsius. It's very inhospitable. However, we know that the upper atmosphere is more hospitable. The temperatures can be even cooler, sort of like what we have here on Earth. And we know on Earth that there are microorganisms that do exist in the upper atmosphere. It is possible that through something called Panspermia, that life could have traveled either from Earth to Venus, maybe even it started on Venus, Venus to Earth, to Mars, back and forth. Life could really be teeming throughout the solar system. I'm going to touch on that more in a second. It is the upper atmosphere where this phosphine gas was detected. And that's interesting because that is where, given all the conditions that we know of, we would expect to see microbial life. So I'm going to go ahead and jump over here to this article, which is talking sort of about the idea of panspermia, or about how life can move between planets. And this article here is on space.com, and this one is Earth Life May Have Traveled to Venus Aboard Sky-Skimming Asteroids by Mike Wall. And I'm going to come down and start here and start talking about this, which is an example of how this could happen. It says, Suraj, a Harvard undergraduate student, and Loeb, who heads the university's astronomy department, drew inspiration from a July 2017 meteor that lit up the skies over Western Australia and South Australia. That fireball was caused by a roughly 12-inch wide, 30-centimeter, 132-pound, or 60-kilogram object that zoomed through Earth's upper atmosphere for 90 seconds. It then resumed its trek through deep space. A recent study by a different research team concluded. It says, such Earth-grazing asteroids could potentially transfer life from our planet to worlds circling other stars. Suraj and Loeb argued in a paper published this past April. So this is talking about panspermia. There's another article on this. I'm not really going to quite get into that. Basically, what has happened is there has been an observation of a meteor that came into Earth's atmosphere and then left. In that trek, in that brief moment that it was here, it could have picked up microbial life and taken it to another planet, Venus in this case. We know that microorganisms do have the ability to survive in the vacuum of deep space. Obviously, tardigrades, we all know, can do this. There have been studies that have shown that they can do this. It's not impossible to think that a meteor at some point in Earth's history has skimmed through our atmosphere and taken life with it to another planet. And Venus is not the only place that we see this happening. Again, talking about panspermia, it is possible that this has been happening elsewhere. So I want to talk about more biosignatures of life on another planet, Mars. And that's where I'm going to come over to this article here. But instead of phosphine gas, like we're seeing being released in Venus's atmosphere, here on Mars, we're looking at methane release. Now, methane is very indicative of life. And it's not to say that it doesn't come from geologic processes as well, because it does. And it is a very abundant chemical throughout the solar system. It was very abundant in the gas cloud created from the nova, which created all of the planets. So we know it's abundant. However, it is very indicative of life. And specifically the fact that on Mars, it seems to be coming and going regularly with seasons. Okay, so coming over to this article here on Earth Sky by Paul Scott Anderson entitled, "Where Does Mars Methane Come From? Not Wind." This article looks at the seasonal methane release. And without trying to read everything, because I totally just did that and realized it didn't work, and I'm going to cut that from the video, without going ahead and reading everything, I'm going to go ahead and just quickly summarize what this is saying is they were looking into different ways that methane could be released from Mars. Again, it is seasonal, so what they were looking at is seasonal wind abrasion and how wind could release the methane trapped within rocks on the Martian surface. And just anticlimactic, it doesn't work. So they have tried to test this or study this and observe this, and they have not found the results that would be congruent with what is happening on Mars. So it doesn't seem like wind is the factor for releasing the methane, which means that a biologic process of methane release is still on the table, and probably still very much the leading reason. Further in the article, we see it states that observations from both orbiting spacecraft and the Curiosity rover, as well as telescopes on Earth, have shown that methane levels in the Martian atmosphere appear to be seasonal, peaking in the summer and fading again in the winter. They state that just why that is not known yet. So I do have a theory here, and of course I think this is pretty standard with anybody that's thinking that this is biological, is in the summertime the microbes are going to be coming closer to the surface. Obviously it's warmer, so they have the ability to move up, at which point you were getting more release of methane gas. In the winter, it is going to be the microbes themselves will be going deeper into the Martian surface until next summer they come out again and we get that methane release. So, this has been followed up on, and I found this article. This article is The Mystery Surrounding Methane on Mars, and this was actually released on the 14th of August, 2020. Let me come into the article and find one specific point that I want to talk about. Alright, I'm coming down to the very end of the article here, under the portion The Mystery Remains. Essentially, the Mars Trace Gas Orbiter, which was led by the European Space Agency, has been trying to track the methane release on Mars. The most recent time that this took place was in late 2019. Quoting the article, "The TGO results were greatly anticipated, and in 2019 the initial measurements were revealed. Nothing. No methane was found down to the detectability limits of the instruments, which was far below that 1 ppb observed by Curiosity. Still, there was controversy. The measurements were taken during one of Mars's infamous global dust storms, which made it impossible for the orbiter to measure the atmosphere all the way down to the surface. Perhaps the methane was hiding close to the surface, or perhaps the dust storm altered the chemistry. Subsequent observations long after the dust storm subsided have still come back with no more than 50 parts per trillion of methane. Despite multiple attempts over many decades to accurately measure methane, and if there, determine whether it is of biological origin, the mystery still remains." So, essentially what happened is the most recent look at the methane release was not accurately able to be done because there was a sandstorm. In the previous article we looked at, we saw that the methane was coming from within meters of the surface. Here, in this article, it states, again, and let me quote, that the measurements were taken during one of Mars's infamous global dust storms, which made it impossible for the orbiter to measure the atmosphere all the way down to the surface. So, realistically, the methane release is still there. So I think this is a very strong argument for the possibility of life to exist in both the Venusian, I hope I said that right, the Venusian atmosphere as well as on Mars. We see these biochemical signatures, methane or phosphine gas, in different areas. And we know that life exists in really extreme conditions here on Earth, and things that, in environments, I should say, that we previously thought were inhospitable. We have extremophile bacteria and microbes that just can exist in situations that we never before thought possible. And if that's the case on Earth, then why wouldn't this be the case on Mars or Venus? I believe that these both could be indicative of life, and I do believe that further research is going to be required to find this. I do believe that if life still exists on Mars, exists at all on Mars or Venus, then it would most likely be microbial. And it's not just to say that those are the only two planets. I believe places like Enceladus, Titan, or Europa would also be good candidates for microbial life. And we might find out that it's a lot more prominent throughout the solar system and maybe even the universe than we expected. We might still be lucky to be the only highly evolved intelligent life forms, but microbial life could really be everywhere. So, that's all for today. After I go back and cut this up and edit it, I hope it flows well. Thank you guys, and be on the lookout for the next video. Peace.